Okay, I think we're ready to start. So, hello and welcome to the next episode in our series of critical infrastructure solutions for the data center. My name is Marcus Doran and I'm the General Manager for High Systems here in Europe. And today's webinar is in conjunction with our partners from the Methode Power Solutions Group. Presenting today is Perry Rodenbaum, who is their lead power electronics engineer, and we're looking forward to his thoughts on how lithium-ion UPS are helping to solve a lot of problems and challenges in the rack and data center space. Before I hand you over to Perry, I'd like to encourage our attendees to use the chat box for any questions that they may have during the webinar, and we'll try to get to those at the end of Perry's presentation. For those that we don't get to, we will circle back and answer those questions individually. So for now, I hand you over to Perry, and thank you again for joining.
Hello, welcome to Solving the Rack Space Problem with Lithium Power. A little background on myself. My name is Perry Rothenbaum. I'm the lead power electronics engineer for UPS design for Methode Power Solutions Group. I have 26 years of design experience in power electronics and controls. Methode PSG supplies power products to military, data center, and other high power sectors. We provide power solutions to UPSs as in our 6 kilowatt UPS, power rails from 200 amps to 2000 amps, embedded bud connectors with capabilities of 120 amps to 400 amps, power cable solutions customized for different products. Same thing with thermal solutions, customized bus bars, and the rails are also customized per solution 200 to 2000 amps. So it's important when discussing UPSs to get some terms straight. So we're going to discuss power. We're interpreting power as the delivery capability, which ultimately determines how many servers and peripherals can be placed in a rack. Size, how high the UPS is and how much space it will take. In the end, if you take up too much space, you could need a whole new rack just to make up for the space lost by the UPS. Weight, although not a critical factor, often weight becomes a factor because the people installing have a say-so in what gets purchased and they don't want something that's 200-300 pounds. Runtime is also important. The UPS may display a good runtime, but it may not be capable of delivering that full runtime over many cycles. So we're going to look at both those cycles and the runtime. And cycles and runtime tend to work against each other, as you'll see. And cycles, of course, is how many cycles the battery can deliver its full power. When you talk to someone about a UPS, you're talking about its power delivery capability. And there's often a confusion between watts and VA. So watts and VA, well, they're both measurements of power, volts times amps. So watts is all the power that goes towards work or heat, and VA, all or some of the power may go towards work or heat, and some is very important here because some may not. So you can have a much larger VA number and yet deliver less work or watts of power. So why not always use watts? It's a true measure of power because amps in the VA is useful for sizing wires, fuses, and circuit breakers. Many people wiring UPSs want to know the current, not the work or heat. Now, conservative engineers will use the same value for VA that it's equivalent in watts. Peak shaving is another feature found in UPS systems. What peak shaving does is it smooths out the power taken from the grid. So as you can see in the little diagram on the lower right-hand side, surges come pulled from the grid, and those surges get pulled when hard drives and servers all power up at the same time or demand energy at the same time. That can result in higher electric bills because the electric companies charge you for the peaks, not the average power. So what the peak shaving does is that the battery supplies the power during those peaks, and it kind of takes it back slowly when those peaks are gone, and therefore you don't get higher electric bills. Also, you can blow breakers if you suddenly have multiple machines drawing large currents. That can also take out test equipment, and it can also take out other servers. So peak shaving is a nice feature to have in a UPS. There are two types of systems for UPSs. One is called double conversion, the other is called single conversion. In double conversion, all of the energy reaches the load, as you can see in the upper picture, by taking power from the grid, converting it to DC, and then reconverting it back to AC, and then delivering it to the load. The reason this is done like this is because when power goes out, it's always being converted, so there's never a flinch or a downtime of the power. It immediately just comes, it's always coming off the battery and off of the DC bank. So there's never a downtime. On the lower single conversion, you see the power comes in and it goes right back out to the load. The eyeball represents the electronics watching the grid, and if the grid fails, it immediately opens the grid, removing the grid, and it closes the battery. Now, you might say, well, then the upper one is more desirable, but the upper one is actually using energy all the time. This double conversion is heating things up, and you have a much higher chance of failure, not to mention it's not that efficient. The lower one, because the electronics is so fast, it can actually switch out the grid and switch in the battery before the load even sees it. This is the way smarter UPSs are working. And its advantage is that it's much more efficient and it wastes much less energy, and it's fast enough to where the load just doesn't see the switch. Another important advantage that lithium ion has over lead acid is the discharge rate. So all batteries self-discharge, and lead acid self-discharges a lot faster, as you can see, 4 to 6% versus 2 to 3%. Batteries can take as long as 4 to 6 months before they actually get a recharge from the time they're put into a product and the time they're actually recharged. So if you think about it, they get shipped overseas. That takes time. When they ship overseas, they're only allowed to be shipped at partial power because it's dangerous to ship batteries at full power. And then by the time they get put into a product, put into a warehouse, put on a shelf, 4 to 6 months. If a battery discharges to zero, it's ruined. Ever kill a battery in your car, drive around a bit, feel it's charged? Well, lead acid has a particular problem. It doesn't like to be partially discharged. So this is good for you to know, whether it's your car or a lawnmower, that if a battery is partially discharged, it'll form sulfates, which will actually grow crystals. And the larger the crystals grow, they harden and they basically become impossible to remove during charging. This is known as sulfation. So the key takeaway here is that lithium ion likes partial charges, has no problem with that. It has a slower discharge than lead acid, and you don't need to waste energy keeping them fully charged, whereas lead acid needs to be charged all the time, fully charged. There are multiple reasons why lead acid is so heavy, besides being a heavy element and bad for the environment. Lead acid operates at 50% of its rated capacity to prevent a diminished life. And by diminished life, what we mean is that if you try to 100% discharge lead acid and have a lot of cycles like we discussed before, you can't do that with lead acid. So lead acid actually uses twice as much material, so you can discharge it not as deeply and still get some sufficient cycles. That creates a lot of extra weight. This chart further shows how the depth of discharge severely hurts a lead acid battery. If you look at the chart, first of all, on the left-hand side, you have a percentage of the capacity left, and we consider at 80% you have no capacity left. That's when you're supposed to change your batteries. If you look and go across that 80 percentile mark, and you look over at a 30% discharge, you can see that the lead acid gets about maybe 1,100 discharges. You can see why they only want to do a 30% depth of discharge and why you need a lot more lead acid, and it gets heavy. Look at the 50%, look at the 100%. If you look at 100% at 80%, you're only going to get maybe 70, maybe 120 discharge cycles compared to 1,000 or 800 that you would get with lead with lithium ion, a much better ratio. All heat hurts all batteries, and lead acid actually has a higher internal resistance, so it heats up more, and that causes lead acid also to wear and lose capacity faster. This chart further shows the devastation that lead acid has from its cycling. As you can see from the chart, that lead acid actually loses capacity as you go through cycles. On the left-hand side of this chart, you can see that at about 75%, 25% of the capacity is lost by the time you get to 256 cycles, which is basically considered dead for lead acid. With lithium ion, notice how even at 500 cycles, you are close to 100% capacity cycle after cycle. Lithium ion delivers the power for many, many more cycles, almost full power, whereas lead acid just starts falling off right away. And keep in mind, these are not the same lead acids that are in your car. These are high performance lead acids, cost a little more money. Your car could never go 256 cycles, it would be dead. So although the initial deployment of a lithium ion might be a little higher, really the payback is over time. You're after about 1.8 years, you're already better off with lithium ion and you're not changing batteries as often. Lithium ion prices are continually dropping. As you can see on the chart on the left-hand side from 2010 to 2015, it's an 80% drop in price, and the price drop will continue. The reason why we're bringing lithium ion attention now is because the comparison to lead acid has never been better, and the time to change to lithium ion is now. The payback is excellent, and it's only going to get better as the years go on. So the point of this presentation is that the time to switch to lithium ion is now. As you can see from the presentation, the benefits are numerous. Prices are dropping and expected to drop further. It's finding its way into power tools, the power grid, telecom, datacom. Lithium ion is finding its way into numerous industries, including automotive, and all of these industries combined is driving the price down further. It's time to educate your teams to the benefit of this great energy source.
Excellent. Thanks for that presentation, Perry. So we have a number of questions that we're going to try and get to from the questions in our chat box. Thanks to those who have submitted those questions, and as mentioned, we'll try and get to them all. So the first question in, with all the bad press on lithium ion batteries, how safe is lithium ion UPS?
Well, actually quite safe. New lithium-ion cells are tested in conditions that are far worse than would ever be experienced in a UPS. Tests include crush tests, or they drive a nail through the cell, short-circuited over temperature tests. A lithium-ion destruction might put out smoke, but they don't catch fire like older lithium-ion cells did. And in UPS applications, any failure mechanism has double protection circuitry. The system measures current, voltage, heat in multiple places. Multiple systems would have to fail for there to be a smoking battery.
Okay, and the second question in, Perry, and it's probably one of the more pertinent ones to this conversation. Why is lithium ion UPS more efficient than a lead acid UPS?
There are two reasons why they're more efficient. Lithium ion has a lower series resistance. This is important because the higher the series resistance, the more energy is wasted. To achieve the same series resistance, a lead acid battery has to become larger and heavier. Two, lithium ion maintains a steady output voltage as it discharges. Lead acid voltage falls as it discharges. As the voltage falls, the load pulls more current from the battery to maintain the same output power. Remember we discussed VA equal power? Well, if V goes down, then A, current, must go up for the power to be the same. More current, more heat, and more wasted power. That means lithium ion is more efficient than lead acid.
And the third question in is, do you see lead acid UPS systems being replaced by lithium ion UPS systems? And if so, in what industries?
Lithium ion is not only replacing lead acid systems, but it's actually creating new industries that couldn't exist in lead acid. For instance, a 16-wheeler truck filled with lithium ion batteries travels to Super Bowl games to provide backup power in case the main power fails. Lead acid would just be too heavy to even make this possible. Anywhere large power backup is needed, lithium ion is often the choice just based on weight alone.
Okay, and the fourth question in, and we have a few more in the chat box, but I think we just have time for one last question. So what are the top 2 advantages of lithium ion over lead acid?
Well, there's a lot of advantages. I guess if I had to pick the top 2 advantages, I would say definitely
lighter is huge, especially when there's large backup power that's being considered. And the second, I would say, is rock solid output voltage throughout the discharge cycle. That's a big disadvantage in lead acid.
Excellent. Thanks for answering all of those questions, Perry. So there's still a few more questions in the chat box, but we'll circle back to those folks that we didn't get time to answer. Perry, I'd like to take this opportunity to thank you for a very informative webinar. And I'd also like to thank the attendees for joining today. If you want to find out more information on lithium-ion UPS from Methode, please take some time to visit our website at www.rahisystems.com. Our next webinar is going to be on the 25th of July in conjunction with our partner Juniper Networks, and they'll be focusing on their security capabilities. We hope to see you all there again. For now, I'd like to thank you for taking time to spend time with us today, and I wish you all the best for the day. Thanks again for joining. Goodbye.